When you receive an EFAS flood notification, it is because EFAS has predicted a significant probability of flooding in your area in terms of reporting points. This notification can be either formal or informal depending on whether it fills or not all the necessary criteria. These notifications are not sent automatically, but there is a number of officers on duty from the EFAS Dissemination Center that analyze the EFAS forecast twice a day and check if there is any reporting points that fulfill the criteria for sending a flood notification. This criteria have to do with the location and size of the catchment, the timing, the magnitude, and the persistence of the forecasts. If we start first on the location and size for one specific reporting point, we see that the catchment needs to be within the EFAS conditions of access and that the drainage area needs to be at least 2,000 square kilometers. Regarding the timing of the event, looking on the hydrograph of the forecast, the start of the event needs to be at least 48 hours into the future from the forecast time. And regarding the magnitude and persistent, we need at least 3 consecutive probabilistic forecasts with at least 30% of probability of exceeding the 5-year return period according to either the ECMWF ensemble forecast or the COSMO-LABS. And in addition, we need one of the deterministic forecasts, so either the one from ECMWF or the DWD also exceeding the 5-year return period. So if all these criteria are met, you're going to receive an EFAS formal flood notification. But if there is some of the criteria that are not met, such in terms of the area, lead time, exceedance, consistency, you might still get an informal flood notification together with some information on why this notification was only formal. If we look a bit more on a specific flood notification, we see that first there is some information on the location of the catchment, the reporting point, followed by the timing, both on the start of the event and the earliest predicted peak, and then the probability of exceeding different thresholds, both for the 5-year return period and the 20-year return period threshold. At the bottom of the notification of the email, you have also a link that will lead you to the EFAS website where you can read on this the criteria that were used to send these notifications in case you have forgotten or you are unsure. You might have noticed that the criteria were not taking into account, for instance, the model performance or the forecast skill or even the impacts. All these aspects are not considered, and you should check them once you receive a notification. You can check for additional information on the EFAS system. We are going to go more into detail on that, but you are also encouraged to check external information. So in terms of whether this forecast, this notification is supported by any other systems like national or local warning services, and even your local knowledge. If we look on the additional information that's available through the EFAS system, there is many types of information, such as the on model performance, on the forecast skill, on the initial conditions of the forecast, but also the processes leading to the flooding and expected consequences. Depending on your area of responsibility, you might be more interested in some of these types of information or others, or even all of them. So it's up to you to get the most relevant information out of the system. We will start by looking at the model performance. Model performance layers are found in the map viewer within the evaluation layers. And there is a layer getting spatial information on the catchment level, giving the general model performance in terms of the Klein-Gupta efficiency, and which you can see in this slide. You see that not all EFAS catchments are calibrated for. So for instance, here you can see that the catchments on the Balkan regions in the Adriatic coast are not calibrated. Therefore, you might expect the model, the predictions to be not as good as for calibrated catchments where the model has good performance. If click on the point layer, the point model performance layer on a specific catchment, you can get more detailed information on different aspects of model performance, such as the correlation, the bias, and the variability. As you can see here with the different speedometers, where the darker shadows of blue indicate a better performance. So you can see that for this case in specific, the model in general has a very average performance in general. But if you look at the different components, it has a very good bias ratio, a very good variability. And what the problem is, or what makes the performance be not so good in this case, is the correlation. So the peaks, the simulated peaks would not correspond that well with the observation. So you might expect a certain lag in this catchment from the forecasts and the model outputs. You can also check if these errors are evenly distributed throughout the year, or they are maybe seasonal. So in this case, you can see a comparison of the monthly averages or long-term averages for the model in the box plots, and the observations on the shadowed areas on the background. And you can see if there are any big discrepancies, or the model is overestimating or underestimating for certain months, and so on. Moving ahead, another layer that you can check for estimating or getting a feeling of model performance is to check whether this specific water course is significantly regulated or not. Under the static layers on the EFAS map viewer, there is a layer that includes all reservoirs and lakes that are included in the least flood model. So a good thing to do would be to check, in case your water course is significantly regulated, if the relevant dams are included in EFAS or not. Depending on that, you might also get a reduced performance of these forecasts of this model. Continuing on the evaluation layers, you have another one which is focused on the skill of the forecasts. This is not for the specific forecast for which you get the notification for, but is a general skill of all forecasts throughout a longer period for this specific point. So if you click on one of the points in this layer, you will get first some information on the volume error that you might typically expect for this location as a function of the lead time of the forecast. So you see that the volume error obviously increases with the lead time, both for the forecast in the solid line, but also for a persistence benchmark that is used to compare the forecast against. Persistent means just to use the same discharge value so extend the discharge value from the last time step of the model. You can also get a direct comparison or a direct estimation on what's the added value of this forecast with respect to this benchmark, this persistence benchmark. In this case, you also have this added value as a function of lead time, and a value of 1 in this case would be a perfect forecast, and a value of 0 would be a forecast that is no better than using this persisted discharge value. So in this case, you see that the forecast is rather valuable for the first lead times, and then obviously its value decreases with time, but it plateaus somewhere over 0.5 or 0.6, which is still some added value with respect to this benchmark. On the EFAS map viewer, you can also check the initial conditions of the model, and you can check different aspects, different states of the model, such as soil moisture, snow, precipitation, temperature, and so on. So you have a lot of information to go through here. In this case, I'm showing an example of soil moisture. You can see the blue shadows indicate high soil moisture, saturated soils, and you can expect those areas to respond directly if there is any precipitation falling. The orange and red shadows indicate a low soil moisture level that would mean that the soil can capture a part of the water that falls from the precipitation and therefore delay the response of the streams. You can also look at the processes that might be leading to flooding, such as precipitation or snow melt. In this case, you can look, for instance, on the meteorological layers, the different meteorological forecasts that we have available within EFAS. And here I'm talking about both the deterministic and the probabilistic forecasts. The one that I'm showing here specifically, that's the deterministic forecast from ECMWF. And you can see that in this case, it predicts quite significant precipitation in the coastal areas of the Balkan regions. But you can also look for specific points, for specific reporting points, how it will look like in the future. So this is the different forecast, the different precipitation forecasts for a specific reporting point. You see there is quite significant and consistent precipitation being identified by all the forecasts. And also you can check again for specific reporting points if there is any upstream snow melt expected in the forecast, and you can check more on the temperature in case it lies within close to zero, and consider the uncertainty of the model to see how any snow melt can look like if there is any minor changes in the forecast. Finally, there is also information on the expected consequences of a given event in the EFAS map viewer. In this case, you might be interested in the rapid impact assessment and rapid flood mapping layers, which can be located within the flood summary layers. The rapid flood mapping will provide an estimation of the extent of the flooding from a specific event. And the rapid impact assessment will give you some information on what consequences can be expected from a certain event. If you click on a certain administrative region, you will get a contingency table of likelihood and impact. So in this case, it's quite high likelihood, high impact event, and also more detailed information on different types of impacts, such as population affected, roads, surfaces, agricultural surfaces, potential monetary damage, if any, and so on and so forth. So this might be quite important for first responders, for instance. If we move on towards the external information sources, as I was saying before, it is important to always compare the EFAS forecasts with other systems, other national or local forecasting and warning services to see if they do have the same views, or the same, if the forecast looks similar. You might also want to check with the latest observations if you have them available. Yes, exactly. I do have some example of a national forecasting system and warning system on the observations, but also quite importantly as well on the local knowledge. EFAS and the model it builds upon, least float, is a continental scale system, a continental scale model, and the very detailed local characteristics, local regimes might in some cases not be perfectly captured. So your knowledge of how it looks like in reality in the terrain is also very important to make the adequate decisions from the notifications that you get from EFAS. The last part here is, once you have received this notification, once this event has taken place or maybe not, it's very important to provide feedback on how relevant was this notification in order to further improve this system to make these notifications more relevant into the future. At this point, we are asking for feedback only from formal flood notifications, but not from informal ones. But in the near future, we will be starting also to collect feedback for informal flood notifications. So if you click on the Leave the Feedback link at the bottom of the formal flood notification, you'll be redirected towards the EFAS map viewer and the feedback providing form. And you will need to answer a series of questions about the event and the notification. So the first question is whether a flood was observed in connection with this notification. If there was no flood, then there is not many questions, only some space to write any comments or remarks that you might have. But if there was actually a flood observed, then we ask for some more information. First, about the event itself, the magnitude, how was the return period, the severity in terms of also water level, economic damages, casualties, and so on, and which processes were the dominant causes of this event. You can select one or several causes and rank them accordingly to according to the ones that are more or least important. Next, there is some questions regarding the notification itself, both in terms of how much lead time did this notification give you before the event started, but also on the accuracy of the notification. And this is accuracy both on terms of location, timing of the onset, timing of the peak magnitude. So quite specific details. And finally, there is a question on the general added value of this notification, of this forecast that you can provide as a simple 1 to 5 scale. You might also provide additional information such as a URL, so you can link to any relevant page, report that is available online, and add any other information that you consider relevant for this notification. And again, providing feedback is very important so that we can continue improving the model, improving the EFAS system, and provide the most relevant notifications possible to you partners.